The night sky is rarely silent. Even in stillness, it moves, slowly, patiently, carrying the memory of everything that has ever been. Above us, the moon hangs like a familiar guardian, constant and unchanging, measuring time in shadows and silver light. For thousands of years, it has guided travelers, shaped calendars, stirred oceans, and inspired myths, whispered beside ancient fires. But on rare nights, something unusual happens. The moon begins to dim. At first, it is almost imperceptible, an uncertainty in the light, a feeling rather than a sight. Then, gradually, a shadow emerges. It does not rush. It does not strike. It advances with quiet authority, as if the universe itself has paused to breathe. Minute by minute, the moon surrenders its glow, and then it transforms. What was once white becomes copper. Silver turns to crimson. The moon, untouched for billions of years, appears wounded, yet majestic. Across the world, eyes turn upward. In cities and deserts, on mountains and coastlines, humanity shares a single moment beneath the same sky. For ancient civilizations, this sight meant prophecy or warning. For modern science, it is a triumph of celestial precision. For the human soul, it remains something more difficult to define. A reminder that even the most familiar objects in our lives can still surprise us. That shadow is not the absence of light, but its companion. And that Earth itself, our home, can reach across space and gently touch the face of the moon. This is the moment when the moon holds its breath. This is the phenomenon of the lunar eclipse. A lunar eclipse is one of the most elegant events in astronomy, a cosmic alignment shaped by light, shadow, and motion. It occurs when the Earth moves directly between the sun and the moon, blocking sunlight from reaching the lunar surface. As Earth's shadow falls across the moon, the familiar full moon begins to change, revealing a process that is both scientifically precise and visually mesmerizing. To understand this, imagine the three bodies involved: the sun, the Earth, and the moon. The sun is the source of light. The moon shines only because it reflects that light. When Earth steps into the path between them, it casts a shadow far into space, large enough to envelop the moon completely. This phenomenon can only happen during a full moon, when the moon lies opposite the sun in Earth's sky. However, not every full moon produces an eclipse. The moon's orbit is slightly tilted compared to Earth's orbit around the sun. Most months, the moon passes above or below Earth's shadow, missing it entirely. Only when this alignment is nearly perfect does a lunar eclipse occur. Unlike a solar eclipse, where the moon blocks sunlight from reaching Earth and can only be seen along a narrow path, a lunar eclipse is visible to anyone on the night side of the planet. It unfolds slowly, often over several hours, allowing observers to witness every stage of the transformation. Another key difference is safety. A solar eclipse requires protective eyewear to avoid damaging the eyes. A lunar eclipse does not. It can be observed directly, with the naked eye, without any risk, making it one of the most accessible astronomical events in the sky. In essence, a lunar eclipse is Earth revealing itself to the moon. It is our planet's shadow projected into space, a reminder that we are not merely observers of the universe, but active participants within it. Simple in principle, profound in effect, the lunar eclipse stands as one of nature's quiet masterpieces, where geometry, gravity, and light briefly align to remind us of our place in the cosmos. A lunar eclipse is not a sudden event, but a carefully timed celestial process, one governed by gravity, motion, and the behavior of light. At the heart of this phenomenon lies alignment. The sun continuously emits light in all directions, illuminating the solar system. The moon, lacking any light of its own, appears bright only because it reflects this sunlight back toward Earth. When Earth moves directly between the sun and the moon, it interrupts this flow of light, casting a long shadow that extends far beyond our planet. This shadow is not uniform. It is divided into two distinct regions. The first is the penumbra, the outer portion of Earth's shadow. In this region, the sun is only partially blocked. Light still reaches the moon, but it is reduced, creating a subtle dimming that can be difficult to detect without careful observation. The second region is the umbra, the darker central shadow where Earth completely blocks direct sunlight. When the moon enters the umbra, the eclipse becomes unmistakable. The moon's brightness fades dramatically, and its surface begins to glow in muted tones. What makes this moment extraordinary is that the moon does not disappear entirely. Even within Earth's darkest shadow, some sunlight still reaches the moon. This light travels through Earth's atmosphere, where it is bent, scattered, and filtered before emerging into the umbra. The atmosphere acts like a lens, redirecting sunlight around the edges of the planet and into the shadowed region. As sunlight passes through the atmosphere, shorter wavelengths, blues and violets, are scattered away. Longer wavelengths, reds and oranges, continue their journey. By the time this light reaches the moon, it has been transformed, painting the lunar surface in deep copper and crimson hues. In this sense, a lunar eclipse is more than a lunar event. It is a planetary one. The color, brightness, and clarity of the eclipsed moon reveal details about Earth's atmosphere. After large volcanic eruptions, for example, ash and aerosols can darken the moon significantly during an eclipse. Cleaner atmospheric conditions result in brighter, more vivid reds. For scientists, lunar eclipses provide a natural laboratory. By studying how light passes through Earth's atmosphere during an eclipse, researchers gain insights into atmospheric composition, techniques that also help scientists study the atmospheres of distant exoplanets. Thus, a lunar eclipse becomes a moment of cosmic reflection. The moon becomes a screen upon which Earth projects its shadow, its air, and its presence, briefly revealing how interconnected the system truly is. Not all lunar eclipses are alike. Their appearance and intensity depend on how deeply the moon passes through Earth's shadow. Astronomers classify lunar eclipses into three primary types, each offering a distinct visual experience. Total lunar eclipse. A total lunar eclipse occurs when the entire moon passes into Earth's umbra, the darkest part of its shadow. This is the most dramatic and widely recognized type of lunar eclipse. As the moon fully enters the umbra, it gradually loses its bright white glow and takes on shades of red, orange, or deep brown. This stage, known as totality, can last from a few minutes to more than an hour. The exact color depends on the condition of Earth's atmosphere at the time. During totality, the moon appears suspended in a dim, coppery light against a backdrop of stars that are usually hidden by its brightness. The night sky feels deeper, older, and more expansive, an effect that has captivated observers for centuries. Partial lunar eclipse. In a partial lunar eclipse, only part of the moon enters Earth's umbra. The result is a striking contrast. One portion of the moon remains bright and illuminated, while the other darkens and may turn reddish. The curved edge of Earth's shadow is clearly visible during a partial eclipse. This curved boundary provided ancient astronomers with early evidence that Earth is spherical, as only a round object consistently casts a circular shadow. Partial eclipses may not carry the same dramatic intensity as total eclipses, but they reveal the mechanics of the phenomenon with exceptional clarity. Penumbral lunar eclipse. The most subtle form is the penumbral lunar eclipse. In this case, the moon passes only through Earth's penumbra, never entering the umbra at all. The dimming during a penumbral eclipse is gentle and gradual. To the casual observer, the moon may appear almost unchanged, though careful viewers can notice a soft shading across its surface. Penumbral eclipses remind us that not all cosmic events announce themselves boldly. Some unfold quietly, detectable only to those who know where and how to look. Together, these three types of lunar eclipses illustrate the delicate precision of celestial motion. Each one, whether dramatic or subtle, is shaped by the same laws of physics, laws that continue to guide the rhythm of the night sky. When the moon turns red during a total lunar eclipse, it can appear unsettling, almost unnatural. Yet this transformation is not the result of fire, shadow alone, or any change in the moon itself. It is instead a subtle signature of Earth's atmosphere written in light. As Earth moves between the sun and the moon, it blocks direct sunlight, casting its dark umbra across the lunar surface. Under normal circumstances, this would plunge the moon into complete darkness. But Earth is not a solid, airless sphere. It is wrapped in a thick envelope of atmosphere, layers of gases that interact with sunlight in remarkable ways. When sunlight passes through Earth's atmosphere, it slows down and bends, a process known as refraction. At the same time, the atmosphere scatters light according to wavelength. Shorter wavelengths, blues and violets, scatter widely, which is why Earth's daytime sky appears blue. Longer wavelengths, reds and oranges, are less affected and continue traveling in straighter paths. During a lunar eclipse, this red-tinted sunlight is bent around the edges of Earth and directed into the planet's shadow. From the moon's perspective, Earth appears as a dark disk surrounded by a glowing ring of red light, created by every sunrise and sunset occurring on the planet at that moment. It is this light that softly illuminates the moon, turning its shades of copper, rust, or deep crimson. The exact color of a blood moon can vary significantly. If Earth's atmosphere is clear and free of dust, the moon may glow a bright, fiery red. If the atmosphere contains large amounts of ash, pollution, or volcanic aerosols, much of the light is blocked or scattered, and the moon appears darker, sometimes brown or nearly black. In this way, a lunar eclipse becomes a diagnostic tool. The moon reflects not only sunlight, but also the condition of Earth's atmosphere. Major volcanic eruptions in history have left their mark on eclipses, producing unusually dark and somber blood moons that were recorded by observers long before the science behind them was understood. The term blood moon itself is poetic rather than scientific, born from the dramatic appearance of the eclipsed moon. While modern science explains the phenomenon with precision, the visual impact remains powerful. The red moon feels ancient, symbolic, and deeply human, a reminder that even the quiet mechanics of physics can create moments of profound beauty. For as long as humans have watched the sky, lunar eclipses have inspired awe, fear, and reverence. Their rarity and dramatic appearance made them impossible to ignore, and long before their scientific explanation was known, eclipses were woven into the beliefs and histories of civilizations across the world. In ancient Mesopotamia, particularly among the Babylonians, lunar eclipses were regarded as ominous signs. Babylonian astronomers were among the first to accurately predict eclipses, yet this knowledge did not diminish their fear. Instead, eclipses were interpreted as warnings from the gods, often signaling danger to the king. To protect the ruler, a substitute king was sometimes appointed during an eclipse, absorbing the cosmic threat until the danger had passed. In ancient China, lunar eclipses were believed to be caused by a celestial dragon devouring the moon. This myth gave rise to communal rituals. People beat drums, rang bells, and shouted into the night sky in an attempt to scare the creature away. When the moon reappeared, the rituals were believed to have succeeded. The ancient Greeks took a more analytical approach. Philosophers such as Aristotle observed that Earth's shadow on the moon was always curved during an eclipse. From this simple but profound observation, they concluded that Earth must be spherical. Lunar eclipses thus became not only omens, but evidence, tools for understanding the shape of the world itself. In the Roman world, eclipses were still associated with unease, often interpreted as signs of impending disaster or divine displeasure. Soldiers were known to tremble during eclipses, believing the gods were withdrawing their favor. During the Islamic Golden Age, lunar eclipses were understood within a framework of divine order rather than fear. Islamic scholars studied eclipses carefully, calculating their timing with remarkable accuracy. Special prayers, known as Salat al-Kusuf, were performed during lunar eclipses, not to ward off evil, but to encourage reflection, humility, and remembrance of the vastness of creation. Among indigenous cultures across the Americas, Africa, and Australia, lunar eclipses were often seen as moments of transition. Some believed the moon was being attacked or temporarily dying, while others viewed the event as a time when spiritual boundaries weakened and communication with the unseen world became possible. Across cultures, one truth remains consistent. Lunar eclipses mattered. They were recorded, remembered, and interpreted because they disrupted the normal order of the sky. Even today, when science has replaced myth with understanding, the emotional power of the eclipse endures. The shadow that once inspired fear now connects us to our ancestors. A shared experience across time, reminding us that humanity has always looked upward, searching for meaning in the darkened moon. Even in the modern world, where the mechanics of lunar eclipses are well understood, their cultural and spiritual significance has not faded. The moon has always been more than a celestial object. It is a symbol of time, emotion, rhythm, and transformation. When its light dims and shifts in color, people instinctively feel that something meaningful is unfolding. Across many cultures, lunar eclipses are seen as moments of transition. The moon, often associated with cycles of life, growth, and renewal, temporarily loses its light before slowly reclaiming it. This pattern has been interpreted as a symbolic death and rebirth, echoing human experiences of loss, change, and renewal. In Hindu traditions, lunar eclipses are considered spiritually powerful times. Some believe that spiritual energy becomes unstable during an eclipse, leading to practices such as fasting, meditation, or avoiding certain activities. Others view the eclipse as a moment for introspection, an opportunity to release negative influences and begin anew once the moon's light returns. In Buddhist traditions, eclipses are sometimes associated with heightened spiritual awareness. Ancient texts suggest that acts of compassion and reflection performed during celestial events carry increased significance, reinforcing the idea that eclipses are moments of alignment between the human and cosmic realms. In many indigenous cultures, the moon is treated as a living presence. A lunar eclipse is not merely an astronomical event, but a moment of vulnerability for the moon itself. Communities may gather in silence, prayer, or song, offering protection or respect while the moon passes through shadow. These rituals reflect a deep relationship with the natural world, one based on balance rather than domination. Modern spiritual movements often interpret lunar eclipses through symbolic language rather than literal belief. In astrology, eclipses are viewed as turning points, times when hidden truths surface and long-standing cycles come to an end. Whether one accepts these interpretations or not, they highlight a persistent human desire to connect cosmic events with personal meaning. What unites these diverse traditions is the recognition that lunar eclipses invite pause. They interrupt the familiar rhythm of the sky and encourage reflection. In a world that rarely slows down, the eclipse offers a shared moment of stillness, a reminder that we are part of something larger, moving in harmony with forces far beyond our control. In contemporary science, lunar eclipses have become valuable tools for understanding both Earth and the wider universe. Far from being mere spectacles, they provide astronomers with opportunities to study planetary atmospheres, orbital dynamics, and the behavior of light. One of the most important scientific contributions of lunar eclipses lies in the study of Earth's atmosphere. During a total eclipse, sunlight filters through the atmosphere before reaching the moon. By analyzing the color and intensity of the eclipsed moon, scientists can infer the presence of dust, aerosols, and gases in Earth's air. This technique has been used to assess the impact of volcanic eruptions and large-scale environmental changes. Lunar eclipses also serve as natural testing grounds for methods used in the study of exoplanets. When distant planets pass in front of their stars, astronomers analyze starlight filtered through those planets' atmospheres, much like sunlight filtered through Earth's atmosphere during a lunar eclipse. In this way, eclipses close to home help refine the tools used to search for life beyond our solar system. Precise observations of lunar eclipses further improve our understanding of orbital mechanics. Tiny variations in the moon's motion, Earth's rotation, and gravitational interactions can be measured during eclipses, contributing to more accurate models of celestial motion. Beyond data and measurements, lunar eclipses continue to inspire curiosity. They are among the few astronomical events that connect professional scientists and casual observers in equal wonder. In observing how Earth's shadow falls across the moon, modern astronomy reinforces an ancient truth. The universe is governed by consistent laws, yet it never loses its capacity to astonish. Through lunar eclipses, science does more than explain the sky. It deepens our relationship with it. One of the most remarkable qualities of a lunar eclipse is its accessibility. Unlike many astronomical events that require specialized equipment or perfect conditions, a lunar eclipse invites anyone with a clear view of the night sky to participate. No telescope is required, no protective eyewear is necessary. All that is needed is patience and the willingness to look up. A lunar eclipse is visible from anywhere on Earth, where the moon is above the horizon during the event. Entire continents can witness the same eclipse together, sharing a single cosmic moment across vast distances. This global visibility has made lunar eclipses communal experiences throughout history. For the best viewing conditions, dark skies are ideal. Light pollution can dull the subtle colors of the eclipsed moon, so rural areas or elevated locations often provide the most vivid views. Binoculars can enhance the experience, revealing fine details on the lunar surface and subtle variations in color as the shadow moves. Timing is also part of the experience. A full lunar eclipse unfolds slowly, often over several hours. Watching the moon gradually dim, change color, and then return to brightness allows observers to witness the mechanics of the cosmos in real time. Photography enthusiasts often use long exposures to capture the deep reds and surrounding stars that become visible during totality. Perhaps most importantly, observing a lunar eclipse encourages stillness. It is not a fleeting flash, but a slow transformation, one that rewards quiet attention. In an age dominated by speed and screens, the eclipse offers a rare invitation to pause, reflect, and reconnect with the sky above. As the eclipse draws to an end, the moon slowly emerges from Earth's shadow. The crimson glow fades, silver light returns, and the night resumes its familiar balance. Yet something has changed, not in the sky, but within us. For a brief time, we witnessed the geometry of the universe made visible. We saw our planet's shadow stretch across space, touching the moon without sound or force. It was a reminder that Earth is not isolated, but part of a vast, interconnected system governed by simple, elegant laws. Lunar eclipses bridge worlds. They connect ancient observers with modern scientists, myth with measurement, emotion with understanding. The same event that once inspired fear and prophecy now inspires curiosity and awe, yet the feeling it evokes remains timeless. In watching the moon darken and return, we are reminded of cycles that shape all existence: light and shadow, loss and renewal, endings and beginnings. These rhythms are written into the fabric of the cosmos and into our own lives. When the next lunar eclipse arrives, it will unfold as it always has, silently, patiently, beyond human control. And once again, people across the world will look up, united by the same shadow, the same wonder. Because in that moment, beneath a darkened moon, we are reminded of a simple truth. We all share the same sky.